let's try to break down the secrets of projectile motion in just 5 minutes. Okay, so look at this. This is what projectile motion is. I like defining projectile motion to be a motion that involves movement in the x and the y direction. I like picturing it combining the free fall motion and linear motion. Okay, I know, of course, we've got cases of talking about projectile motion, maybe just in the y direction. The projectile motion, in its sensible case, is something like this. So what we are saying is, if you've got a ball, for example, it's going to be moving both in the x direction and in the y direction. This is what projectile motion is. Now, what are the secrets of projectile motion? Things that can help you to deal with this in simple ways. Okay, so I've got five. The first thing that you need to know is you should understand the vectors. Okay, by understanding the vectors, I mean you should know that for you to find the x component, it's going to be given by the resultant of a vector cosine the angle, and then also understanding that in the y it's r sine of theta. Why is this important? This is important when you're talking about a ball and then it's projected at a certain angle. Okay, let's say 30 degrees. This is very, very key because you're going to be given this velocity to say maybe 10 meters per second, or a ball is thrown at 10 meters per second 30 degrees above the ground. Okay, so for you to find the velocity in the x direction, you'd have to use that 10 meters per second. We can call it v, and then cosine the angle 30. The same applies to the y. So this is why it's important for you to understand the vectors. Okay, that's the first thing that you need to know. Very useful, very applicable, because the velocity in the x and the y are different. The second thing that you need to understand are the equations of motion. So most of these things that I'm already mentioning you, I believe you already know them. So the three equations of motion is v is equal to u plus at, which I believe you already know. And then the most important one is this one. S is equal to ut plus half a t squared. Of course, the third one as well, v is equal to u squared plus 2as. Okay, so I'll try to convert the most important one, which is this one, in the form of projectile. So when I'm dealing with projectile motion, the displacement, we call it the height in this case, is equal to this velocity. Can depend on whether you're talking about the x or the y axis. Now let's try to talk about this in terms of the y axis. Since we've said our displacement is h, so it implies we're going to consider this equation in the y axis. Okay, this is dependent on the third point that I need to make, which is very, very important even before I write down the equation, which is that you need to understand that under projectile motion, the x and y motions are independent of each other. They are independent. Okay, in the next point, you're going to understand that the velocity in the x direction is actually constant throughout. So when you launch this ball, for example, throughout motion from that point up to the point where it's going to hit the ground, the velocity in the x direction is basically going to be constant. Velocity in the x is always going to be constant. Velocity in the y changes because it varies due to the acceleration. When it's going up, you would understand that it's actually negative g because it's working against gravity. When it's coming down, it's what? Positive gravity. So that's why this point, the third point, is very important, which would now get us to a point where we're going to say h is going to be velocity in the initial velocity in the what? In the y direction. So v y naught. So in other terms, if we express it in terms of the velocity itself, it's going to be v naught, and then this is y, so it's going to be sine of the angle, and then t. When we are going up, the acceleration is going to be negative, so it's going to be half g t squared. This equation is the most important equation when we are trying to study projectile motion, and you're going to see us use it. Okay, so these are the three things that I've already told you. I've told you to say you need to understand that we're going to be using this, the x is that, the y is that for the vectors. And then the equations of motion, I believe you know them already. I've shown you how to convert the most important one to projectile motion. And then I've told you the x and the y motions are independent of each other. The fourth point I've already mentioned, where I've said in the x direction the velocity is constant, and then y it varies due to the acceleration. And I've said when you're going up it's negative, when you're going down it's positive gravity. And yeah, basically these are the five. This was supposed to be the last one, so this is very important. And I think I need to mention to say for the y, at the maximum height at the maximum height, you would understand that the velocity in the y axis is 0 at that maximum point. Okay, so yeah, these are the basics of projectile motion that you need to understand, and if you apply them very well, it will be easy for you to answer questions. Now let me try to show you how we can apply these principles of projectile motion that I've given you to answer exam kind of questions. Let me try to show you how they can actually work. So I'll start with the first one. Let's call it A. Where are we going to have the ball? Where will the ball be in 2 seconds? Okay, so where will the ball be? So this is a position question. What position? Okay, so of course what we have here is we've got a golfer who is eating a ball, and then this ball is hit at a velocity of 45 meters per second at an angle of 20 degrees above the ground. Okay, so where is this ball going to be 2 seconds later? Now when you're talking about projectile motion, you need to understand that basically there are two things that is happening, which I've already mentioned. The ball is going to be moving both in the x and in the y direction. So if you have to determine the position, maybe let's say that's a position. If you have to determine the position of this ball, it means you need to give the movement in the x and then the movement in the y as well. So it should be x comma y to give the position of the ball. So how do we find the movement in the x and how do we find the movement in the y? Take note, time has been given. Okay, so I did emphasize these two are independent of each other. Okay, so one key point that I did mention for the x is I said in the x direction the velocity is what? Constant. So for you to determine the distance that has been covered after 2 seconds, you just need to determine the initial velocity in the x. So the initial velocity in the x is going to be Vx is going to be V naught and then cosine of the angle. This is going to be velocity in the x direction. So V naught there we understand is 45. So 45 cosine 20 degrees. This is the velocity in the x direction. Now we understand that it's constant. So for us to determine the distance covered in the x direction, we just need it, because remember we understand that distance is actually speed multiplied by what? Time. Since we understand speed is constant, in this case of course velocity, yeah, so 45 cosine 20 degrees multiplied by the time, which is 2 seconds. Okay, so if you multiply that, you're going to get 84.57. This is meters in the x direction. So you've seen that we've actually determined the distance covered in the x direction without saying anything about the y direction. Okay, now how about the y direction? This is now where the equation that I mentioned is very, very important. So take note, for the x we've determined 84.57 meters. So in the y direction, I gave you a very important equation. So I said h is equal to, so this is coming from s is equal to ut plus half at squared. Now it's going to be h, and then let me just write it for you again so that you see how everything is coming about. So s is equal to ut plus half at squared, Now we're talking about the y direction. If you want, you can use h or y for the distance in the y. So I'll use y for this case. The initial velocity in the y, how is it going to be? It's going to be v and then sine of the angle and then multiply by time. Since we're going up, the gravity is negative and then time squared. So y is equal to, so y is representing the distance to be covered in the y, and then we now understand this is going to be 45 sine of 20 degrees. The time was 2 seconds minus half 9.8 times 2 squared. This actually makes sense why it's a negative, because we understand as we are going up, there is what? We are actually working against gravity. So the velocity should actually be reducing. Okay, so what is the answer? So 45 sine 20 degrees multiplied by 2 minus 1 over 2 multiplied by 9.8 times 2 squared. So I'm getting 11.18 meters. This is for the y direction. Okay, so I've already demonstrated to say the x and the y are independent of what? Of each other. And so as a good student, you want to present a position even as a coordinate 84.57, 11.18 in the y. Okay, so I've shown you how we've determined them independent of the other. Okay, so I've got a lot of questions that we can actually look at. So there could be a question to determine the maximum or the highest point. Okay, remember I was saying that. So let's try to determine the maximum height, right? How do we find the maximum height? Using this principle that I've told you to say the x and the y direction are independent of each other. How do we find the greatest height? What can you picture? Is this question related to the x direction or the y direction? So one thing that we know is that at the maximum height, the velocity in the y is going to be what? It's going to be 0. Now we understand that at the initial point, the velocity in the y at the initial point is going to be v sine what? Sine 20 degrees. So we've got the initial velocity in the y, and then we also have its final, which is 0. So how do we basically determine the highest point or the maximum height? Understand that at the maximum height, our velocity is going to be 0 in the y direction, and then at start it's v sine 20 degrees. So we can actually use that principle to help us determine the time it's going to take, right? If you go to the first equation of motion, v is equal to u plus at, this equation is what it relates the final and the initial velocity. So we've got the final, the maximum height is going to be 0, the initial is v sine 20 degrees, which is 45 sine 20 degrees, okay, and then plus the acceleration as we are going up is negative 9.8, and then the time. So we can find the time using this equation. We can see it's the only unknown variable. So I have 9.8t is equal to 45 sine 20 degrees, then divide both sides by 9.8, and yeah, the time I'm getting is 1.57. So 1.57 seconds. So time is 1.57 seconds. So how is this time going to help us determine now the height? Okay, so you can now go back to the most important equation, which I've already given you, where I said the height is equal to, so ut minus half at squared. So ut minus half, in this case gt squared. Now this point, when you're dealing with the y direction, the initial velocity, remember we said is what? It's v sine 20 degrees, which is 45 sine 20 degrees, and then the time is what? The time is what we've just found to be 1.57. Okay, and then minus half 9.8, the time again is 1.57, and then squared. Okay, so yeah, grab your calculator and try this one out. So what would be the height? So the height I'm getting is 12.08. Okay, this is of course going to be in meters, right? Yeah, meters. Okay, so what is our height? Our height is 12.08 meters. Okay, so you've seen that basically when it comes to looking at these questions, approaching them with the understanding that the x and the y direction are independent of each other, it all makes things easier for us. Okay, now I want you to pause the video and just try out this one now. Think about the time of flight. Okay, so find time of flight. Okay, so what is time of flight? Of course, time of flight is the total time that it actually takes the boat to move or complete the entire projectile motion. That's what the time of flight is. So find the time of flight, and then I also want you to find the range. So the range is the total distance covered in the from this initial setting point to the last point. This is the range. So the easiest way to find the range is just to use the x direction, since we understand that the velocity in the x is constant, so we can actually determine the distance covered horizontally. That's what the range is. Okay, so if I ask you for the horizontal distance, the range, they're all referring to the distance in the x direction of the entire projectile motion. Now, before you can find that, it will be easier for you. First of all, you find the time of flight. Okay, pause the video and just try that out. Okay, so I want by all means possible just to restrict the number of equations that I'm using so that it's easier for you to answer different questions. So use this equation again, the one which is coming from linear motion. Okay, so now this equation, what you need to understand is this y value, or the h, whatever you're going to call it, is actually representing the displacement in the y direction. Okay, now displacement basically does use direction. Okay, so one thing that you need to understand, if I'm going this way, if I've covered the displacement that way, let's say 10 meters, if I start coming back from that same point and come back this side, it's going to be negative 10 meters. So the total displacement is 0. That's the way displacement is. Distance, on the other hand, this would be 20 meters altogether because there's no direction. Okay, so that's very important for this statement here. So using this very equation, let's try to determine now the time of flight. So meaning that we need to find the time. Gravity we already know. Now what is the displacement to be covered? So if you look at the kind of projectile that we're dealing with, something that is perfect like this. Okay, so when we discuss the movement in the y, we are first of all moving from bottom there up to that maximum point, and then from the maximum point we're getting down. So at the end of the day, the displacement is going to be 0. Okay, so when you're finding the time of flight in this equation where there's y, you put a 0 for that very reason. And then the initial velocity that we need to appreciate for the y direction, the initial one, we always have to go back to the initial velocity. So that will be 45 sine 20 degrees. This is why understanding vectors is key. And then we don't know about t, minus half of 9.8, which is our gravity, and then our t squared. So you see that we actually end up with a quadratic equation in that sense. So 0 is equal to, and then what do we have? So 45 sine 20, um, that's giving me 15.39 t, and then half of 9.8 is 4.9, so t squared. So at this point we can, instead of using the quadratic formula, since we only have two things, we don't have a constant. If we had a constant there, we would use a formula, but we don't have a constant, so we can just factorize. We can see t is common. What would remain with? If we pull out the t, we remain with 15.39 on the first part, and the other part will remain with 4.9 t there. And then this is just equal to what? That's just equal to a 0 in that sense. Okay, what else do we do here? Okay, so at this point we have to suppose now find the values of t. So we understand that when you factorize, you can get that equated to what is on the right. So in one case t is equal to 0, in the other case get what is in the brackets and equate it to 0 as well. Now we're going to end up with what? 15.39 is equal to 4.90 if it crosses the other side, and then divide both sides by 4.9. So you discover that actually our t becomes equivalent to 3.14 seconds. So we found time twice, and we have two answers. Are any of you able to think of the reason why we have two answers of time? Okay, where displacement is 0. So actually displacement is 0 twice. At the point when before you launch, when t is equal to 0, we haven't covered any displacement, so at that point our displacement in the y is 0. And then again, when you go up, it's a maximum displacement. When you get down again, they'll cancel out, it's also 0. So this is representing the starting point, this is representing the final point. So 3.141 seconds is the time of flight. Okay, so this equation should become your friend, and yeah, and then finding the range becomes easy because you know the range is the distance, horizontal distance covered, and then you understand that velocity in the x is actually constant, and then you understand the time of flight, you've determined it to be 3.14. So you just substitute the velocity in the x, which is constant throughout motion, is 45 cosine 20 degrees. The time of flight is 3.141. You multiply the two, you get the distance in the x direction, which is 132.8 meters. Okay, so you've seen how we were basically using this you've basically seen how we're using the understanding of the independence between the x and the y direction to be key. Okay, so let me give you two try out questions, and I want you to comment down below. If you're a person who wants to understand the different kinds of projectile motion, where you're on an eye on a building, you drop, and then also what other kind of projectile motion do we have? There's also just again on the is this case where it just drops like this. Okay, which is actually the first one out of them. Now there's also one where you go up like this. Okay, so all these has been covered more in detail. You can actually check out the membership videos, or actually go to Patreon. The links are all provided for you in the description below. Yeah, or either Patreon or membership on YouTube, or even our site, you'll be able to access this topic and other physics topics in full detailed videos. Now I want to try out these two questions. The first one is I want to determine the time. How long does it take to reach a height of 15 meters? Let me not say 15 meters. Let me just say 9 meters. And then secondly, I want you to try out um, imagine at the end of this is a tree. Okay. Yeah, don't mind the drawing. Imagine there's a tree. The tree is just at 12 meters, and then it's 80 meters away from that initial point. um, Now the question is it going to pass over the tree, or it's going to eat into the tree? That's what the question is asking. So will it or pass over the tree? Okay, given that it's 80 meters away in the x direction and it's 12 meters I. Okay, so I want you to comment in the I want you to give us a comment about this question and tell us the answer. Yeah, pretty much that's it. I hope you've gotten a few things that will help you to understand projectile motion faster and just handle different questions. And yeah, thanks for watching.